Welcome back, everyone, for another AI News Deep Dive. We've got a fresh batch of research papers straight from arXiv.org, hot off the press, covering the latest and greatest in machine learning, computer vision, and natural language processing.
Every day it seems like we see something that pushes the boundaries of what we thought possible with AI.
Like this one that caught my eye. Imagine an AI that can understand your emotions, but not from your facial expressions, from numbers.
It sounds pretty sci-fi, but researchers are finding new ways for large language models, or LLMs, as I'm sure everyone's used to hearing them called by now. To interpret those emotions, they're using these things called valence arousal values.
So these values basically capture how intense and how pleasant an emotion is. And then the LLMs use that to describe someone's facial expressions. It's amazing how closely they matched how a human would describe them.
It really opens up a lot of possibilities for AI systems that can interact with us on a deeper level. Maybe we'll even see AI assistants that can actually empathize with us.
That'd be incredible. But can we really capture all the nuances of human emotions? I mean, think about feelings like ambiguity or mixed emotions. Can we really boil those down to just numbers?
That's a great question, and it's definitely something we need to think about carefully. This research is exciting, but we can't forget the limitations of AI, especially when it comes to something as complex as human emotion.
Well, this next one almost sounds like it's straight out of a sci-fi movie. An AI that can design its own experiments.
Have you heard about automated capability discovery? It's changing how we evaluate AI. Imagine an AI that can create tasks to test another model. It could even test itself.
So instead of humans designing the tests, the AI is in charge of its own evaluation.
Exactly. That kind of self-exploration could help us discover things about AI systems, things we might not have even thought to look for, like hidden talents or weaknesses.
It's like having an AI scientist constantly pushing the boundaries.
It makes you wonder what else AI could automate in the future.
Okay, let's talk about something a bit more practical. The huge amount of computing power you need to run these giant AI models.
It's a real concern, but researchers are finding ways to make LLMs more efficient and accessible.
Like this new approach I saw called GPU Adaptive Non-Uniform Quantization, or GANQ.
You can think of it like compressing a large file. You're shrinking these massive models down so they can run on less powerful hardware.
So maybe someday you could run powerful AI models on your own computer.
That's the goal. It could really democratize AI research and development. Even small teams or individuals could build amazing AI-powered applications.
Speaking of making AI accessible, let's talk about how it's being used to fight climate change.
Climate change is one of the biggest challenges we face, and it's great to see AI being used to develop solutions.
Researchers are now using AI to monitor CO2 storage, which is a critical part of fighting climate change.
They're creating 3D digital models of CO2 plumes and using AI to analyze seismic data. That helps them track how CO2 moves underground.
That's so important for these carbon storage projects. AI can help make sure they're safe and effective.
It gives us a much more accurate picture of what's happening underground, and that helps us make better decisions about managing climate change risks.
It's amazing to see AI being used for a more sustainable future.
This is just the beginning. As AI keeps evolving, we'll see even more innovative solutions to global challenges.
Now let's jump into the world of drug discovery. AI is revolutionizing this field.
Drug discovery can take a lot of time and resources, but AI is making it faster and more efficient.
Imagine an AI chemist tweaking existing drugs to make them better and safer. That's what researchers are doing with Drug Improver GPT, a new large language model built specifically for optimizing drugs.
It analyzes the relationship between a drug's chemical structure and its properties, and then suggests changes that could make it more effective and reduce side effects.
It's reward-driven, meaning the AI learns to prioritize improvements based on specific goals, like making the drug work better or making it less toxic.
This could be a revolution for personalized medicine. Imagine treatments tailored to your specific genes and health conditions.
AI could even help develop drugs designed just for you.
It's a whole new era for healthcare.
Let's move on to a topic that's vital for building trust in AI: robustness and generalizability. We need AI models that can handle unexpected situations and make the right decisions, even in complex scenarios.
That's right. AI needs to be reliable, especially as we start using it for more important tasks.
This paper about memorization and diffusion models is really interesting. Diffusion models are so versatile, they can generate images, simulate biological processes, even predict the weather. But there's a worry they might accidentally memorize sensitive information from the data they're trained on.
Yeah, that's definitely a concern, especially when it comes to things like medical records or financial transactions. But researchers are developing ways to prevent that. They're making sure diffusion models can be used responsibly without compromising privacy.
It's a big step towards building AI systems that are effective and respect our privacy.
Privacy is key. As AI becomes more integrated into our lives, we need to make sure it's used ethically and responsibly.
Now let's talk about protecting AI from backdoor attacks.
These attacks can be dangerous. They exploit weaknesses in AI systems to manipulate how they behave.
So an attacker could insert a hidden trigger. That would make the AI make bad decisions.
That's right.
So how are researchers addressing that?
Well, there's this promising approach called fuzzed randomized smoothing. Instead of trying to find and remove the backdoor, they're making the AI less vulnerable to it in the first place.
So they're strengthening its defenses.
Exactly. They identify the vulnerable parts of the input data and then randomize them, which makes it much harder for attackers to exploit those weaknesses.
It's like adding another layer of security.
This research is so important for building trust in AI, especially as AI systems become part of critical infrastructure and decision-making. Security has to be a top priority.
That's a great point about security. There's this new research about a potential vulnerability in Whisper, that popular speech recognition model. Oh yeah, Whisper's open source, right? So anyone can use it, which is great. But it also means more people are looking for weaknesses.
Exactly. This research looked at how Whisper might be biased toward certain accents or speakers, especially those that weren't well represented in the training data.
So someone with a strong accent might have trouble being understood. That's not just a technical issue, that's a fairness issue.
Absolutely. They use this interesting technique called K-nearest neighbor search. It basically gives Whisper access to more speech samples while it's running.
So it's like giving it a cheat sheet to adapt on the fly.
Yeah, you could think of it that way.
Does that mean it can understand more accents without needing a massive retraining?
Exactly. It did improve accuracy, but more importantly, it showed us where there might be biases. Biases we need to fix if we want speech tech to be inclusive.
It's important that AI systems can understand everyone.
It would be a real problem if only certain voices were heard.
Okay, let's switch gears a bit. This next paper deals with something fundamental to AI, the idea of rationality.
Rationality seems straightforward, but when you apply it to AI, it gets complicated. This research dives into how we even define rationality, especially for AI systems that operate in the real world.
So are they saying that what looks like irrational behavior could actually be the best choice, depending on the situation?
It challenges our assumptions. They argue that even seemingly irrational actions can be the optimal choice in certain contexts. They also bring up the issue of interacting with irrational agents, both human and AI.
That adds a whole other layer of complexity. How do you even begin to negotiate or collaborate with something that doesn't follow the rules of logic?
It's a tough question. This paper forces us to rethink how we approach AI development. Especially as AI systems become more autonomous, we need to think about real-world decision-making, not just ideal rationality.
Let's move on to something a bit more concrete, weather forecasting.
Even something as familiar as weather forecasting is being changed by AI. Researchers are using machine learning to improve data assimilation. That's the process of combining observations with model predictions.
But weather models are already incredibly complex. How does AI help with that?
They're using these things called surrogate models, basically simplified versions of those complex simulations that can run much faster.
So faster predictions. But are they as accurate?
That's the key question. This research shows that these surrogate models can be surprisingly accurate, even with incomplete or noisy data.
Faster and more accurate weather predictions? That sounds pretty good to me.
It's a step towards a future where AI helps us understand and predict the weather with even greater precision. That could mean better preparedness for extreme events and better resource management.
This next paper is about using AI to uncover the secrets of the universe. Okay, maybe not the whole universe, but it's getting us closer. They're using AI to automate something called parametric modeling.
Parametric modeling is basically finding equations that describe how things are related. Think of it like finding the mathematical formulas that explain how the universe works.
But finding those equations can be incredibly difficult and time-consuming.
Right, that's where AI comes in. This research introduces a framework called symbol fit, which uses a technique called symbolic regression to automatically search for those equations.
So it's like an AI mathematician that can analyze huge amounts of data and find those hidden mathematical relationships.
That's a great way to put it.
And they're not just finding equations, they're also figuring out how confident they are in those equations.
Yeah, that's a crucial part. They're not just giving us answers, they're telling us how much we can trust those answers.
By including uncertainty estimation, SymbolFit gives scientists a more complete picture.
This could be a game changer for scientific discovery. Imagine the new knowledge we could uncover if we could automate the process of finding those fundamental equations.
It could accelerate research in physics, chemistry, astronomy, all sorts of fields.
It lets scientists focus on the big questions, while AI does the hard work of finding the mathematical explanations.
Now let's talk about something a bit more personal. Recommendations. Imagine having a conversation with your AI assistant, and getting recommendations that are tailored to your tastes and preferences.
Conversational recommendation systems are getting more advanced, but there's a challenge in combining the flow of conversation with the power of collaborative filtering.
Collaborative filtering is like when you get movie recommendations, based on what other people with similar taste have liked. But how do you make that work in a natural conversation?
That's what researchers are trying to figure out. They've created a new dataset that links conversations on Reddit with movie ratings on Movie Lens.
So they're combining the richness of conversational data with the insights from user preferences.
Exactly. And they've developed a framework that uses this combined data to make more accurate and personalized recommendations.
It's like having an AI friend who knows your taste in movies.
And can recommend something you'll love based on what you're talking about.
This takes personalized recommendations to a whole new level.
Imagine getting suggestions for anything: products, books, travel destinations, all perfectly aligned with your interests, and all through a natural conversation.
It's like AI is anticipating our needs.
And providing us with recommendations that truly make our lives better.
Speaking of making our lives better, let's talk about regional weather forecasting.
Accurate weather predictions are so important for agriculture, transportation, disaster preparedness, you name it.
And this research is pushing the limits of what's possible with regional weather forecasting.
They're using a really smart approach, combining high-frequency observations from local weather stations with coarser resolution outputs from atmospheric models.
So they have both a close-up view and a wide-angle view of the weather.
Exactly. They developed a model called MIMA, short for micro-macro, that combines those two types of data using a transformer architecture.
It's like an AI meteorologist that can see both the details and the big picture.
And it works really well. MIMA is more accurate than existing nowcasting models, especially for short-term predictions.
That's impressive.
They even made an extension called REMA that can make predictions for areas without weather stations.
That's huge for regions where data is sparse.
It could really improve forecasting accuracy in remote areas, leading to better preparedness for extreme weather and better allocation of resources.
Okay, let's talk about something that's key for making AI more practical and scalable: neural network pruning.
You can think of neural network pruning like decluttering a room. You're getting rid of what's not essential, making it easier to find what you need.
But how do you know what to get rid of without hurting performance?
Researchers are developing techniques to identify and remove the less important connections or neurons in a network. This paper introduces a framework called sequential attention ++A, which combines efficient pruning with optimal results.
It's like having a gardener who knows exactly which branches to prune.
Exactly. Sequential attention ++ guides the pruning process intelligently and achieves state-of-the-art results. It's a big step towards making AI models more compact and efficient.
Now, this next paper tackles a really interesting challenge in AI learning: reinforcement learning in situations where you can't just reset and try again.
Most reinforcement learning assumes you can run multiple trials, learn from your mistakes, and then start over. But in the real world, that's not always possible.
Right. Think about a self-driving car. It can't just hit the reset button if it makes a wrong turn.
That's a great example. This research looks at non-episodic reinforcement learning, where the agent learns from a single, continuous stream of experience.
So it's like learning on the fly.
Exactly. They've developed an algorithm called NeoRL that embraces uncertainty and encourages exploration,
So instead of sticking to what it knows, it's encouraged to try new things.
even if it means making some mistakes along the way.
And it actually works.
They've shown that this approach leads to better performance over time.
That's pretty cool.
It's a step towards more realistic and adaptable AI systems that can learn and thrive in the real world.
Okay, ready to dive into the world of glycobiology. It's a field that's essential for understanding biological processes and developing new drugs.
Glycans are these complex carbohydrate structures that play a crucial role in all sorts of biological functions.
But they're incredibly complex, right? How is AI helping us understand them?
Traditional methods have had trouble capturing the higher-order relationships between different parts of a glycan, but this research introduces a new approach, using something called higher-order message passing in graph neural networks.
So it's like giving the AI a more powerful tool to see the intricate details of these complex structures.
Exactly, and it really improves the accuracy of various glycan-related tasks, like predicting their properties or classifying them into different types.
This could lead to new breakthroughs in drug discovery and personalized medicine.
It's another great example of how AI is helping us unlock the secrets of biology. We were talking about complex structures before. This new research in topological deep learning is really interesting. It's making this powerful technology more accessible.
Topological deep learning always sounded a bit intimidating to me, like something only mathematicians could really understand.
That's what's so cool about this. This framework called TopoTune makes it much easier for researchers to use.
So now regular AI folks can use it too.
Exactly. It gives you a user-friendly way to build and train these powerful neural networks called Generalized Combinatorial Complex Neural Networks, or GCCNs for short.
GCCNs.
They're designed to understand those complex, higher-order relationships in data.
And they actually outperform traditional methods.
They do. They tested them on a variety of tasks, and GCCNs consistently got better results.
So they're really good at extracting meaningful insights from complex data.
This is a big step forward for topological deep learning. It's becoming a much more practical tool.
Okay, let's talk about another important area for making AI more efficient. Memory management in large language models.
Those models are getting bigger and more powerful, but they also need more memory to run.
It's like trying to fit a library into a backpack.
Researchers are always looking for ways to reduce that memory footprint without sacrificing performance.
This paper introduces a new technique called AQUAKV. It focuses on optimizing the memory usage of key-value caches in LLMs.
Key-value caches are like the LLM's short-term memory. They store information that needs to be accessed quickly.
So AQUAKV makes those caches more efficient.
By compressing the information stored in them.
It's like packing your backpack more efficiently.
Exactly. They've managed to significantly reduce the memory usage of LLMs while still maintaining accuracy.
That's impressive.
This could make LLMs much more practical for running on devices with limited memory.
This next paper is about automated theorem proving, but with a really interesting twist. They're using self-play to train LLMs for this task.
Self-play has worked really well in games like chess and Go, where the AI plays against itself to learn.
So in this case, the LLM is playing both sides of the theorem proving game.
That's right, it proposes theorems and then tries to prove them.
It's like a constant battle of wits with itself.
Exactly, and it's leading to some amazing results.
The LLM is getting much better at proving complex theorems.
It's actually surpassing previous methods.
Imagine AI collaborating with human mathematicians, pushing the boundaries of what we know.
It's an exciting thought.
Okay, let's dive into something a bit more abstract. Density ratio estimation.
Density ratio estimation is all about comparing two different datasets and figuring out how they differ.
This paper introduces a new framework for doing that, based on something called conditional probability paths.
It sounds complicated, but the basic idea is pretty simple. They're bracing how the density ratio changes as you move between the two datasets.
So they're looking at how the datasets gradually transform into each other.
Exactly, and they've developed a method that's both efficient and accurate.
This could have a lot of applications, like detecting anomalies or understanding causal relationships.
Even abstract mathematical concepts can have a big impact on the real world.
Well, that's it for our deep dive into the latest AI research.
It's been a whirlwind tour.
We've covered so much ground today, from humanizing LLMs to optimizing weather forecasts. What stood out to you the most?
The sheer amount of innovation is incredible. The progress in drug discovery, the focus on AI safety and robustness, the advances in fundamental techniques like density ratio estimation. It's all so exciting.
It really shows the power of AI and how it's transforming our world.
And as we've seen, it's not just about making AI more powerful. It's about making it more responsible, more accessible, and ultimately more beneficial for everyone.
That's a great note to end on. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible with AI.